Okay. Up to 17. Okay, so um I think I'll start by apologizing for not getting the videos and notes up as quick as I hope. I keep getting distracted. It's been really busy. Um, I am gonna try to do that after the class. I actually, amazingly, I think my calendar is clear for like the first time. And I did take the weekend off. I don't know. I haven't done that in a long time. I actually didn't work. That's why I fall behind. Can't can't take the weekend off. But I'll get the stuff uploaded to the site, and I'm thinking, I don't know. We don't have much time left. Um, I was thinking of asking you to write a type checker um, for like that we went over in the last lecture for the language with procedures. And I guess did they have, I forget, I don't think he had arguments in there. And there's type checking. Or did he? Typed bump. Let's see. Um, yeah, he had arguments in there. So that's a good thing to see. You know, uh, I once had a student who took this class and who then went on to take databases. And in, I don't know, the old days in databases, you had to build a SQL interpreter. And the guy came to me and said, with his code, and he said, I can't get this thing to work. And he had just taken 4780, where we're building a lot of interpreters in here in case that's not registering with you. It didn't register with him. Um, so, and then I looked at his code and he wasn't parsing. He had also taken 3015 where we did parsing. He wasn't parsing. He was just trying to take the SQL input strings and going back and forth across them, setting flags if certain things were true. And it would be virtually impossible to make that work. So I hope you realize that you can apply these techniques in other situations in a lot more than you think if you go into solve a problem with the mindset that, oh, maybe there's a way to like treat this like a little language, even if it's a language that no one ever sees. You can design the language and then design a parser for it. So anyway, um, I'm hoping that you get that, but I don't know. I have a feeling that's it's hard to get that. And why won't that open? Okay. All right. So anyway, any questions about anything and the homework? I don't know. I guess that's past due, isn't it?
Yeah, it was due yesterday.
Yeah. So maybe we'll have 2 more homeworks And I don't know. I'm mixed on what to do about the final, but I mean, we'll figure something out. So anyway, let me share my screen. Today, what we're going to look at is um, we'll look at Huddle's implementation of records. Um, you know, there are a lot of um, more complicated. Um, I think what I'm trying to say is I think it makes it maybe more complicated to do the kinds of simplifications or corrections that I want to do. Like, I guess maybe I just have to write my own book. I've got all the code now, basically. Um, and so we'll do it with his environments, all mainly because I have code here for that. So let me share my screen. Let's see. Can you see that? So you should be looking
Yeah.
at the syntax of and this is of this language, which he calls burr, which is on page, you can't see it there at the top, 136. This is the definition of burr. And so anyway, wow, there was years ago when I used to teach out of this book, and I still use it as a reference to help me out when I can't figure out what Burr is exactly trying to do, or to try to help fix what he's doing. I'm going like, this doesn't have to be as complicated as he's making it. But I remember at some point I was like going away. I was teaching the class from this book, and I was going away to a conference. So it was going to be away. So I gave them extended homework. I said, look, implement records as described in the Schmidt book. And I came back like, missing a class, like, on Thursday or something. It came, and everyone was just freaking out. No one solved it in the entire class. No one actually figured out how to implement records as they're described in the Schmidt textbook. And one guy got close, and I went and I looked at it, and I saw that his description was in error. And so, um, and now what I look at, and when I look at my book here for Burr, it's kind of a mess. Um, he he makes a lot of typos, and it's really sad to have all these typos. But I think I've got most of them marked in mind. In the future, we're going to look at some different parts of the rules and so forth. There's quite a few typos in there, but the main thing that gets added in this section is this very cool way, and this is like a useful thing, I think, to know in general, of how to make a data structure, how to build records, how to build records. And these are the names that are going to go into records. And so you either have, X, which is just a variable name, or you have P, which is just a procedure name, or you have an R dot X, and so R is part of the record name, and R here is part of, they're all strings. X, P, and R are all strings, but you've got this recursive structure here that lets you make R, which is a string, dot, and then X, or an R and then a dot and a P. So, R, well, sorry, wrong writing instrument. Um, R is in R, X, and P are all strings or identifiers, right? We might have more rules. We don't want people to name variables, space. Um, in the, I work. I mean, I don't know. I guess I'm pretty old, but Fortran's older than me. But I worked at a Fortran compiler where you could say 0 = 1, and you would rename 0 to have the value 1. Now, there was a bug or a potential source of major bugs. You would have a heck of a time figuring out what was going on when all of a sudden 0's behaving like 1, or, um, something like that. So anyway, you might want to have identifiers, and you might want to have the identifiers rule out keywords. Like you might want to not, it's not just a string, because you don't want to allow the symbol plus. You don't want to allow the symbol times. In a real compiler, you'd have to take care of those things. But we're assuming that, okay, they're identifiers which are in some way reasonable identifiers. So now everything pretty much stays the same, because, and maybe he does this a little bit nicer than Schmidt does, because A expressions look exactly the same, except that this X used to be a lowercase x, so it was just a string. But now you could refer to a record value. Now, it's also the case that this is where type checking becomes kind of interesting, but I don't think we're going to be able to get to that. So, A and B essentially stay the same. These two things stay the same, except for this X is different instead of just having a lowercase x there. And we've got statements they're the same, except that now when we do an assignment, we can refer to an X. So notice that he did, keep these are variable names, X's, and P's are procedure names. And so over here we have a P, and over here we have an X, and otherwise, everything else stays the same. And now the big thing is we add this statement. Instead of just being able to declare a variable and declare procedure, we now can declare a record, and the declaration for records looks like this. And so records have the keyword record in front, then the name of the record, and then a series of declarations of either a DV, a DP, or DR. Okay, and that's one other difference. You can have a record declaration in here. And so this one allows you to do that. And then, of course, all these are recursive in this way. But now a record is this is like a struct in C, or I don't know, what do you call it? Do they still call them structs in C++? And so anyway, this is going to give us a way of defining a structured data type. So any questions about the syntax? I mean, it's really this thing here and this thing here that are the big changes. And, otherwise we're going to have to, update this, and we're going to have to account for this, right? So he adds Oh, and I didn't photograph it, but he adds a, and so I'm going with this idea that we're going to have um, three different environments, and so now we have, um, and there's a typo here actually. So but in ENVP he's got a typo, but in ENVV is going to be equal to, oh, I'm sorry. Var union next. Oh God. All right. I'm not going to include the next. Var arrow loc. And of course the store is still a map from loc to int. And the ENVR, the new kind of record environment, is going to take an R name and map you to an ENVV, an ENV paired with an ENVP, paired with an ENVR. So you're basically, a record is going to take a name and map you to the environments for that record. And you can think of these nested environments as being maps that show you where to go. So I'll show you that in a minute. I just want to show you the error here in case you read the book, or and wanted to write code from the book. He's got an error here. This one goes from p name to, you got to have the statement in there, which is the body, and he forgot the statement. Um, and otherwise, you got to have, um, just like you do for records, you need to have all the parts for p names, because you could put a procedure down in the record, right? So let's see, what is it? Like, I don't know. Let me try and write an example of a record. So we could say like record uh, R1 equals var x colon equals 2 semicolon. Oh, there's no semicolons. Oh, or the semicolons may be built into his record syntax. Yeah, they're built into the, like, they're not really a syntactic thing. They're in the semantic side. So I could say var x equals 2, and then I could say proc p is x gets the value of x plus 1. And then I could say record R2 is equal to var y colon equals 3 semicolon. I could say var x. And then I could say I don't know. Can I do that? Can I say then, like proc q is call r1.p? That I'm not sure about, if you can call the record from down inside the record. Well, we'll see when we look at the semantics. And then he has, on the record syntax, he has an end. So this is an example of a record, and this X, okay, call P, let's say semicolon, well, let's say begin, call P, R1.P, sorry. Let me make this a little bit more complex. Let's see. Now, this I'm not sure about either. What is his semantics going to do for this if I did this? It might not allow it. It could be that I have to always use once we're in, once we add, I think in the next thing he adds some facility for doing this kind of thing, where this X would refer to this X and not to that X. But I could say like here I could say R1 dot X gets the value of R1 dot R2 dot Y plus 3. I'm not sure we can do this, but anyway, we'll try it. We'll see what happens. Questions? So, what would go in the, like, what would R1 look, well, let's see, what would what goes in, we can look at the types of the environments, and we can figure out exactly what this structure would be. And that's actually probably a really good thing to try and do. So let me see if I can figure out how to display this properly. Okay. Gosh, I wish there was a way to zoom. Did somebody tell me how to zoom out? Somebody knows how to zoom out?
Isn't zooming out like control scroll or
Control.
in like scrolling on your mouse wheel, I think.
No, I tried that last time. Looks
control
like
minus. Control minus is working. Yeah. Okay. Okay. I still need a little more space. Now, is there any way to get across here? No. All right, let's see if we can figure out, though, what this is going to look like. So we've got all these parts. So we're going to have, I'll say and V. Let's make first, like, so what you can do is you could sort of think of, okay, look, this is going to be some kind of environment. Call it ENV1. What does ENV1 look like? ENV1 is a map well, I guess I don't know exactly how to do that. I mean, it's a begin end. So let's say, what does R1 look like? Because each one of these individually is going to be its own, well, there's going to be like an ENV and a proc part for this, right? But so let's look at, what does R2 look like first? So let's call this ENV2. And so we've got a map that takes the name R2 and maps it to, and if we look at what the R name maps it to, is we've got an ENVV, and in that one we have that Y goes to, and if this went to loc 0, then this one went to loc 2. I better check his semantics. Like, he could be doing this lazily, and then you instantiate a record. So what does he do for vars? It looks like he's trying to do it lazily. Now let me see. How does he do it for vars? Yeah, he allocates new storage. Okay. So that means Y goes to loc 1, and also in there is another one that says X goes to loc 2, and that's it for the var part. So I've got this part for this, and now there's the P or the Q part, and Q goes to, so this is my I should write it in a different color. This is the var part. And then this is the proc part, is the next part. And that says Q goes to, and so then we have the statement begin call R1.P semicolon R1.X gets the value of R1.R2.Y plus 3. And so there's the statement. And then this gets tucked away with what? What's the environments that go in with this procedure? And I think we probably want the environment, this var part, I got to give it a name now. ENVV1 or 2, I guess. And then this part is the ENVP2. I don't know. I'm making this up as I go along, trying to figure it out. So what do I put in here? I think I put like an ENV2, and think I've talked about this union operation, which glues together two environments. So this is my var part. Where ENV is the environment that we had coming into this part. And then what's my proc part? Well, here's where we would determine whether this would work or not, and whether this would work or not. And I think this could all work if we just put the right, what's the right? It's ENV proc question mark. We don't know what to put in there yet. So here's my statement. If you look over here, I'm trying to build the statement, then the variable environment is what I have when I process this thing, plus the variable environment that I just declared up here. And then for ENVP, I'm not sure. We probably, if we put Q in there, then we get recursion. So I'm not sure what we want to do here yet. And we'll see what he does in his rules. And then the ENVR that we have at this point is questionable also. But could it be that we've got, R1 maps to, I don't know, maybe we're not going to allow this recursive record structure right now. So this probably is just empty. But we'll see. So this is the record part of the environment. And then that's all that goes into this environment. So if I built this environment for this part of the declaration, this is what it would look like. Oh, I should scroll up a little bit. Sorry. So now I can write the part for R1 pretty easily, right? The record part for R1 goes to an environment that has X going to loc 0. And that's the only variable that's declared there. And then we have P going to, first of all, the statement, X gets the value of X plus 1, followed by a var environment, which I think should probably be, when we reach this declaration, there's going to be an environment in place already for variables. And let's see, what does he pass into the rec declaration? Maybe we should look at that. We'll look at that next. But yeah, he passes the variable, the procedure, and the record environment. So this is something like, ENV, which is the environment that was current when the call was made with, so ENVV, the variable part, with X updated to go to loc 0. So that's the var part, proc part. And then the R part is just, this record that we just constructed over here. So call this whole thing over here R2 in ENV. And so then this just becomes R2 ENV. I guess I actually need, technically, I need parentheses around these to make these triples, right? This is a triple. And now I'm done. So R1 would look like that with this whole thing nested in it. And so now you can see the idea of like what happens when I try to look up R1 dot R2 dot, you know, let's say look up R1 dot R2Q. So let me go right over here more. So if I try to look up R1 dot R2 dot Q, and, you know, let's call this whole thing as the R1 ENV. So this is the R1 ENV. So when we do a lookup, though, we need, he passes the variable part and the record part, I think. Well, for an assignment, but what about an A expression, for example? And what is that equal to? Well, you go in this record and you look up the name, look for the name R1. Now, there could be other records in here, right? I could have said record R1, and then I could have said record R2, and then I could have nested another R3 in there. But we look in this record and we say, is, you know, R1 mapped to something? Because that's the first part of this name here. And if it is, then we get that record or that package. And then we say, okay, now what is the R2? And we look and see, is it, well, we also, I should say, we also know that this is a, we know that this is something of the type P in the syntax here. We'll know that. And so we'd say, okay, maybe at this point we go and say, look and see if R2 is in the P part. No, we know we're not there yet. So we only go to the, when we're looking for this, we have to be going to a record because we're not there yet. So then we go down and we look for in the record part, and the record part is this part over to here, and we say, is there an R2 there? And it says yes, and it maps to these things. And so then in there we say, okay, and now we're looking for a Q, and Q is a procedure. So we go to the proc part and we say, is there a Q in there? And if there is, now we have the information to get to Q. So this could be, you know, like, so if I said like call, oh, I'm down a little bit too low. If I said like call R1.R2.Q, the first thing that would happen is, you know, it would do a lookup like this to get the definition of Q, and then it would build the call, do the call. So does that make sense? Tim, ask a question. I see you going like, what? Thanks for having your video on, by the way. I don't know. I wish I could sort this so that anyone that has their video on is at the top of my screen, because I see Isaiah has his on and no one else. I don't know. There is some way to do that, but I don't know how to do that. Okay.
So my question is, in your environment for R2, I'm trying to get the uh, equation correct. So you have at the bottom for the proc part, you have Q and then the whole statement. Then you have the ENV2 union ENV V? Or what is?
Yes, I don't know yet. We need to look and see what he does. I'm
Okay.
guessing that he does something like that.
Okay, and then you have ENVP.
But I mean, this would be one sensible thing that would enable you to say you at least can refer to variables that were declared in the variable part of this record, right? Because every record consists of a variable part and then a procedure part and then a record part. And like when you look at the old block, when we didn't have DR here, these guys could refer to that. So I feel like this has to either be, you know, okay, take this ENV that we built here and use that. Oh, and, but you also need, you know, this could happen in a series of declarations. You could have one record, then another record, then another record. So, you know, after you have one record, the next record should be able to refer to the previous record that you defined. So we have to keep building the environment as we go through this thing. And he probably, we'll look at that next. We can look at those rules next. Because,
Okay. My question is, so the record part, is that equivalent to the uh, the record part you have written down that's just labeled record part? Is that your ENVR?
yes, but this one is empty because there's no records after R2 in this declaration. So there's no other records for it to read. If there had been a record previous, and I'm not sure, I mean, this probably has records in it that were, it would have definitely records in it that were declared previous to this one. But let's say, you know, this was the beginning of our program and this was one record. Otherwise, this will be whatever record was in, or whatever record environment was in place at the time that this record declaration was encountered. But then the question is, what does he do for records in that sequence? And we can go look at that rule next.
Okay, so that record environment doesn't have R1?
That's a question. I'm not sure.
Okay.
We're going to have to look at his rule. It could have R1. But then you've got like the possibility of, I bet it doesn't have R1, but I'm not sure. Well, let's look at it. Let's go find it. I'm going to go there right now. Anybody else have a question? Isaiah, how you doing?
I'm doing good. It makes kind of sense.
Okay. It's like the records are a map eventually either to a procedure or a variable in our case. Those are the final endpoints. A record itself, it's just a map. So let's go look at, I don't know. I think it might be this one. Okay. Let me get there on my iPad also. Let's see. It's 159. I think this is the one where records are declared. What happened happens if I do? No, that doesn't, I don't like that. Okay. So if you look, so here's where I think when you try to implement this code, you kind of discover there has to be an error here, because if you look back at like the so these are the rules on the top are procedures, and these are for record declarations. Now, procedures don't, I mean, I can sort of almost see exactly what's happening here. He was editing and he copied this rule down here, and this one doesn't have the store in it. But the variable rule, which is probably, I don't know. I wonder if I can, let's see, copy. I'm going to go to I think this is the variable rule. Now, these are the rules for going through names, variable names. That's table 9.1. Okay, I don't want table 9. Why do I have that twice? Okay. No, I don't want the arithmetic. I hope I got a photo of it. Oh. Okay, here's the var rule. So first, let's look at the var rule. And I think, in a way, the key is that the var rule has a store in it. So notice we don't have a complex name here. We just have var x. Because when we're processing the record, we're going to get down and we're going to see, like we did in the example before, we'll get to a record and there'll be a variable declaration. And then what we want to do is create an environment for that sequence of variable declarations. So, all right, let me go to this one. This is photo 158. But see, I guess the point of coming here is that to show you that he needs the store to be able to well, he's mislabeled this thing also, hasn't he? Oh, okay. No, I was saying, oh, he only has the record environment. But see, he's not going to change the record environment in any way. So it's kind of like to the left of turnstile, because that's extra information you need to look things up. And you don't need the procedure environment at all. So in here, he has the record environment to the left, and then he has, the variable environment is going to change. So you're going to return that, and the store is going to change. And so let me go to that one on my iPad so I can write on it. Let's see, it's 158. Okay. Oh, I see. It would help if I just turned this way. So suppose that, I guess I'm a little confused though. Okay. Why does he need the record environment? He needs it to evaluate this initial value A. Okay, so if you look here, you say like, okay, what does he do to evaluate, to build? What he's really doing is he's building a new environment that knows about this variable and a new store that has that variable declared. So suppose we have, let's just take the simple case where we don't have a record, anything in ENVR, it's empty. We don't have any records yet. And we run into this, we say, okay, var x colon equals a, and then I'll say semicolon epsilon, and then suppose, whatever S is, some store. And what is that going to go to in the rule DV? So this is the declaration rule. This is how you, declare a thing. And then he does this horrible thing. I mean, the first thing he does, though, is common, right? He takes, this is ENVR. He takes the empty one and he takes, oh, wait, I forgot to put the ENVV in here. Because the first thing that goes in is the variable environment. And suppose we haven't seen any, or maybe let's say we've seen a Y that goes to loc 0 is what was previously been seen. And the store, I'm not going to bother to write down what's in the store yet. I mean, we might have to understand this. And so then I go on a DV and I'm going to go to a pair, which is an ENV. And what we want here is an ENV that should have X and Y in it, right? This one should have been expanded. So how does it get there? So we don't know what that is yet. We don't know what that is yet, although we know it's going to be the store where loc 1 goes somewhere. So what does he do? He says, okay, evaluate A. So let me make A concrete. Let me not say X equals A. Let me say X equals, 7. And so I evaluate 7 in this store S, and I get back 7 for the value of A. So then what do I do up here? I bring up the empty ENVR. And now I look at epsilon, and I bring up ENV. Okay, and here's where I think he made a mistake. Yes, he wrote, first of all, see, there needs to be another prime on this because he's using this name over here, but this one, is the result of evaluating that. So that's going to be different than that. So we can't, so for us, it's epsilon dv, and then we're evaluating with ENV prime. And ENV prime is the one that knows that, first of all, we get the next loc, and so assume that next of a next ENV, oh, right. This thing all has 2 entries in it. If we really want to write this down like fully formally, there's a comma there, and then there's a next entry, and I think next should go to 1. So this thing here is my ENVV. And so when I use that now up here, what do? I use that same ENV. I take ENV and I update X to point to the new location. This is the declaration of X. And I update next to be one more than it is. So we've got E, and then up here we get, it doesn't matter what order I write them in. Next goes to 2. Y still goes to loc 0. And Z, or I'm sorry, X goes to, tell me what. You might forget, like new log K is equal to log K plus 1.
Loc 1.
Right. So that's my, this is my ENVV prime. And then my store is one that has had loc 1 updated to be the value of A, which was 7. So L is loc 1 and V was what we got from evaluating A, and our A is the number 7. So this says loc 1 gets the value 7 plus. I mean, it's not hard for me to write it down. I can actually explicitly write out the entire store, right? Because when we came in here, what did we have? We had loc 0 pointed to something. All right, let me move this stuff over, although I'm running out of space to the right. So this is the store that says loc 0 goes to, I don't care, 11, comma. Oh, and that's all that's in it, right? And so now we've got a new store. It's not S updated with that. The new store is, if we write it down explicitly, it's the one that says loc 0 goes to 11, comma, loc 1 goes to 7. And so where do we go over here? So now on the top is where we get the answer that we're going to bring. So the way the information flows in this stuff is from the left side here of the arrow, including this, goes information that's flowing up to just to construct this. And then there may be a DV could be an arbitrary thing, number of variable declarations. And then information is going to flow down from above here. But we don't have anything from above because we're evaluating this rule. And it says when you're evaluating epsilon, you just return those. So I just return ENV prime here. And this store, I'll call it, S1. And so that's the answer over here. Okay. So that was a variable declaration. And what's going to happen if we had other variable declarations? Like if you did this a little bit wrong, you could end up and I think I might have done this in the code, first version of code that I sent out somewhere, and maybe it's still out there in one of your homework. You could end up allocating variables backwards so that like the last one gets the lowest location number going and the first one gets the highest, right? If you didn't update this properly and build it up properly.
Where does the log 0 is 11 come from?
That was just in the store when we encountered this rule. So this was kind of like, this was given, this is, S. Okay, call this maybe S2, and this was S1. And this was, I can write it in red. What came in, this was given to us. This is the next statement was given, this is given, and this is given. So those are kind of like the inputs that we know when we come to start to evaluate this thing. And then what do? Well, we evaluate this thing, but the epsilon rule says, okay, just take the environment that you have and return it, and return the store also, whatever store you have. So we got to return S2 here. And then this becomes S2.
So in this example, what would happen if ENVR wasn't empty, if there was something else there?
Nothing in this example, but it's possible that you could have, this thing here is our A expression. You could have an A expression. It's perfectly okay to have something like, R1 dot R2 dot X plus 3 is an acceptable A expression. And so it's possible that I need the ENVR, I could write that a little clearer. Spell it out a little clearer. ENVR. I would need, if my A expression was like this, I need to use R. Of course, without type checking, oh God, so let's see, without type checking, you could have an ENVR that had a bunch of entries for records, or you could have the empty ENVR. And when you try to do this, or you tried to look up this expression, you'd go here and say, is there an R1? And it would crash because there is none. But if you type checked it, you would guarantee that everything is consistent. You would guarantee that you would never have an A expression that refers to R1.R2 without having a record in here with that structure. And it must have an X in it also. So the type checker helps a lot once you have structures, especially, or records. So let's go. Any other questions? If we go look at, I think, no, it wasn't that last one, was it? No, it's this one. Come on. Give me the corner. Okay, there we go. Oh, come on. I'm going to make you bigger. I don't know why it jumps back. I go maybe a little bit too far. Okay. So procedures are easier because the only thing that possibly changes is environments, but no nothing to the store. Now, it is interesting though. Let's see. We wondered how do they do it so that see, I don't know. This is just a little bit brain damage to me here. Now he's saying it's R.P. How do you look that up? Why didn't we have one of those rules for variables? Did I miss it? I didn't see it. No. I mean, look, maybe I just didn't photograph it. I thought I got all the. He calls these record, the dotted record notation generalized variables and generalized procedures. So like on the bot in the middle of page 138, which is the page just before this thing, he forgets to put the store in there when he's talking about variable declarations. So I don't understand why he doesn't have, maybe he mentions it, but he does in the text. He doesn't have, for this one, here's a rule where the name is just proc p is s. And then he has more rules for when you have a r.p. And basically what you do is he figures out what the environment is. Even if this was like r.r2, he'd end up getting r2, or the map that's in r that's named r2, and he'd get that, and then he'd use that up above. But he uses the, why does he not use the variable part up here though? He doesn't use, I don't see, I see a ENVV coming back. In his previous rule, did he have something in here? Okay, the proc one only returns an environment, the straight up proc one. So I don't know. I'm a little bit confused. Okay, right. So that's going to return, when you look up this P, you're going to find that. Let's look at the record one though. I'm just thinking though that it looks to me like if you're down in a record R, so you've got ENVR and it knows that R is a record, and here's your variable environment. It doesn't seem to me like it's this variable environment is made available to when you evaluate S. Something's wrong with this, because where does this come from? I think he means this to have a single prime. Oh, wait a minute. Where, and then maybe. Okay. So what I'd claim is with his rules, he can't do the program that we did over here. Oh, come on. Where is it? we can't do this program because you can't refer to variables inside the record that you're currently declaring, I think. It looks to me like the environment, this environment for this previously encountered stuff doesn't get put in there. So you look up R and you get back a triple, ENV prime, ENV P prime, ENV R. And then what? You only pass up the ENV R and you pass up P. And eventually you get to P. Okay. And then this stuff comes down, except that, okay, so there was a rule for looking up this rule. I guess I'm a little bit confused about that rule. It seems to me, though, like our program won't work. It looks to me like it does not allow so this is finally when you get down to an individual procedure name. Okay, so this thing is the same as this, transition rules for generalized variable names. I'm sorry, I should have looked at this more before we started. But, you know, I don't know. On the one hand, some of you might be sitting there going like, oh, you know, I can't wait to get to the evaluations. Caldwell comes unprepared. But I kind of feel like it's not bad to see like how I'm puzzling it out. Because you sort of see a process to look and figure out like, what am I looking for? Okay. This is how you resolve these names. So this is pretty straightforward. But we only have 1 minute. So if you had like an R1.R2.x, what would happen here? You'd have, this would be R1 and this would be R2.x. So you would look here and you'd go like, okay, go up here and look up, first of all, figure out the environment R, and you get these three things. And now use ENVR prime and ENVV prime to figure out what R2.x is. And so then you go and you get the environment for R2. And then that's the one finally you're looking up X. And so then you just look up X gets L, the value L in that variable environment. So that's how you chase down a name that's one of these R1.R2.R3 things. And then what's going on here, he didn't add like a generalized variable name rules. I don't see him here. Maybe he says write down, you know, could be an exercise he leaves the students. I don't see it though as an exercise. So this is missing something because this X here could be a capital X. If we go back and look at the syntax. Oh no, it's a lowercase x. Okay. All right. Well, anyway, I guess class time's over. I'll upload the notes, and I think what I'm going to do is I'm going to give you the code that we've been working on with the parameters, and I'll give you working version of the code. So if you is there anyone that hasn't handed in their homework yet? Well, like if I didn't bring this up, then people wouldn't even know. I think I did this before and didn't tell anyone that the new code had the answer for the previous one. But if you're working on homework 3, you're not looking at homework 4 code yet. So anyway, I'll give you the answer to the last problem in or even we don't need recursion. Without recursion, you'll work from the same code base that you were given for the last problem. And now what I want you to do is implement the type checker that we talked about last time, which is described in chapter 13. Okay? I'll write that up, but I'm not going to like give you the type checker. Maybe I'll give you one line or something. But you're going to have to read chapter 13 carefully and then translate his thing into code. And I think it's actually pretty correct. I don't know. I guess I have to look at it a little bit more closely. All right. Thanks. Adios.